Hello everyone, today we'll talk about the problem intersection of two arrays 2. We're given two integer arrays and we want to return an array that is their intersection. That is, if an element of some value appears A times in the first array and B times in the second array, then in our result it should appear the minimum of A and B times. The order in our result doesn't matter. There are two main ideas to solve this problem. First idea involves some form of counting the number of times an element appears in one or both the arrays. And the second idea does not involve counting, but iterates over elements and somehow makes sure that it includes them as many times as necessary in the result. So first, the counting idea. One thing that we can do, of course, is either to count the elements of the first array and then go through elements of the second array, decrement the count in the first array, if it's possible, if it's positive. So if we can decrement it, we decrement it and add this element to the result. Otherwise, we have run out of elements of that value from the first array, so we just cannot add them to the result anymore. And even simpler would be to count the number of times every element appears in the first array, the number of times it appears in the second array, and just for each element take the minimum, as I mentioned at the beginning. In Python we can use the counter data structure for it. So we can initialize a counter with nums1 and nums2. So this will be essentially a dictionary from value of element to the number of times it appears. Now the intersection of two counters would be exactly what we want, the intersection of those two arrays. And to convert it back to an array, so back to a list in Python context, we just use the elements method. So that is the counting method, which gives us a nice simple one-liner solution. And the other solution is based on the idea that we can just go through all the elements, and essentially if we could, for every element in one of the arrays, mark it in the second array that it's used and add it to the result. And if we could that quickly, then that would solve our problem. And indeed we can do that quickly. However, to do that, we have to first sort both of the arrays. Because now that the arrays are sorted, then we can go from the left. Our elements are only going to stay the same or increase. So we can easily, instead of finding a given element in the second list blindly every time, we can, by only pushing the index forward, so by looking only at the elements from the left to the right, we can make sure that we do not miss any element, that we do not use any element twice. So here we have an index that points to the first unused element from our first list. We go through all the elements in the second list, and now we want to find that element in the first list. So for as long as the element that we're pointing at in the first list is smaller than this element v, then we know that we cannot include it in the result, we just have to increase our index. Now that this is no longer the case, maybe we are pointing at exactly an element equal to v. That means that we have found a pair of matching elements, so we add it to the result. And we, of course, push the index forward as well. And at the end we can return the result. So in other words, every sorted array will include some blocks of elements of the same value. Maybe some of those blocks will have values that do not exist in another array. So let's say something like this. And here we can have a 1, 2, 3, and 5. So what we do is essentially, whenever we have two matching blocks, then we just match them element by element. Same here, element by element. And this is one way of implementing that as a simple for loop, and another index that goes from left to right in the other array. So this part is linear, so this whole complexity is dominated by sorting of both the arrays, which will typically be in linear logarithmic time in n log n.